Trigonometric integrals. The goal is to evaluate the integral of the form sine to the m of x cosine to the n of x dx, where m and n are whole numbers. For odd powers of sine of x, for example, evaluate the integral sine cube of x dx, where the power is 3. We rewrite sine cube of x as sine of x times sine squared of x. We keep one copy of sine of x, where sine squared of x is 1 minus cosine squared of x. And so the integral of sine cube of x dx is now the integral of 1 minus cosine squared of x times sine of x dx. Let u be cosine of x. Then du is negative sine of x dx. This is the reason why we kept one copy of sine of x. This one copy of sine of x will be negative du. The integral is now 1 minus u squared times minus du, which is the integral of u squared minus 1 du. Evaluate the integral, we have 1/3 u to the third power minus u plus c. But u is cosine of x, so the answer is 1/3 cosine cube of x minus cosine of x plus c. For odd power of cosine, and there is a factor of sine in the integrand. For example, evaluate the integral of sine to the 4th x cosine to the 5th x dx. We rewrite sine to the 4th x cosine to the 5th x as sine to the 4th x times cosine to the 4th x times cosine of x. We keep one copy of cosine of x and rewrite all of the factors in terms of sine of x. Simplifying this, we have sine to the 4th x minus 2 sine to the 6th x plus sine to the 8x times the quantity cosine of x. We then let u be sine of x. Then du is cosine of x dx. This is the reason why we kept one copy of cosine of x. The original integral sine to the 4th x cosine to the 5th x dx is now the integral of sine to the 4th x minus 2 sine to the 6th x plus sine to the 8x times cosine of x dx. But u is sine of x, so this is the integral of u to the 4th minus 2u to the 6th plus u to the 8, and cosine of x dx is now du. The antiderivative is therefore 1/5 u to the 5th minus 2 times 1/7 u to the 7 plus 1/9 u to the 9th power plus c. But u is sine of x, so the answer is 1/5 sine to the 5th x minus 2/7 sine to the 7x plus 1/9 sine to the 9th x plus c. With the case where neither sine or cosine appears with odd power, for example, evaluate the integral of sine to the 4th x dx. We will reduce the power of sine using the trig identities. Sine to the 4th x is sine squared of x squared, where sine squared of x is 1/2 times 1 minus cosine of 2x, the whole quantity squared. We then expand this to simplify into 1/4 times the quantity 1 minus 2 times cosine of 2x plus cosine squared of 2x. This is 1/4 minus 1/2 cosine of 2x plus 1/4 cosine squared of 2x by multiplying 1/4 inside the bracket. But cosine squared of 2x can be reduced to 1/2 times the quantity 1 plus cosine of 2, and the angle is 2x. And so this is 1/2 plus 1/2 cosine of 4x. Sine to the 4th x can be rewritten as 1/4 minus 1/2 cosine of 2x plus 1/4 times 1/2 plus 1/2 cosine of 4x. Simplifying this, we have 1/4 minus 1/2 cosine of 2x plus 1/8 plus 1/8 cosine of 4x. The integral of sine to the 4th x dx is now the integral of 3/8 minus 1/2 cosine of 2x plus 1/8 cosine of 4x dx. The antiderivative of 3/8 is 3/8x. The antiderivative of cosine of the 2x, half of it, is 1/4 sine of 2x. And the antiderivative of 1/8 cosine of 4x is 1/32 sine of 4x plus c. In this problem, we use the two identity. Sine squared of theta is 1/2 times the quantity of 1 minus cosine of 2 theta. And cosine squared of theta is 1/2 times the quantity 1 plus cosine of 2 theta. This is also known as the double angle formula.